School of Mechanical Engineering is one of the faculty in engineering campus of USM. The initial objective of the school establishment was to produce high-quality graduates in mechanical engineering and manufacturing engineering to fulfill the high demand for professional specialized workers by industry in Malaysia. The program of Manufacturing Engineering with Management is launched to nurture manufacturing engineers who can design and manage the processes and systems to make products with required functionality to high quality standards at the best possible price and in ways that are environmental friendly.
Bend radius, which is measured to the inside curvature, is the minimum radius one can bend a pipe, tube, sheet, cable or hose without kinking it, damaging it, or shortening its life. The smaller the bend radius, the greater the material flexibility. Sheet metal is popular due to its strength, durability, and manufacturability. When you design for this medium, there are some guidelines that you should follow, especially when it comes to bending it. One of the important features is called the sheet metal bend radius. When you bend sheet metal, the material compresses between a punch and a die. The punch is backed by tons of pressure, and the punch business end determines the internal bend radius. The resulting inner bend won't end up with a square of 90-degree angle, as it is impossible to get a completely sharp bend. No matter what, you'll always have a curve, which is how it gets the name the bend radius.
So now we'll see how the sheet metal bend radius will affect the part size of the product. The amount of metal in the bend affects the final dimension of your part. When bending sheet metal, the material stretches. So to ensure accuracy, we add what is called a gain. We always think about that and we factor that in when creating the flat pattern that becomes your part. From a designer perspective, all we need is your final geometry. We take it from there so you can get the part that you were expecting.
So now we'll discover how tight the internal bend radius can go. If a piece of material is bent too tightly, problems can occur. The most common problem with bending a piece of sheet metal too tightly is that you can compromise the structural integrity of your sheet metal form. Basically, you might create a weak point in the metal that can break easily, lowering the maximum load the metal can take before shattering. Another common issue with bending a piece of metal too tightly is that there can be excessive plastic deformity resulting from the stretch of the bend, slightly altering the dimension of the final workpiece along the area where the bend was made. So, with this in mind, what do you think that minimum internal bend radius should be for a piece of sheet metal? There are two major factors that affect how tight you can make the internal radius of a bend in a piece of sheet metal, which is the hardness of the metal and the thickness of the metal. Generally speaking, the thicker a piece of sheet metal is, the wider the internal bend radius will have to be. Similarly, the harder a piece of metal is, the more room you will have to allocate for the bend as well.